So you've probably played around with ChatGPT, right? Or seen some of these AI tools that feel, well, like pure magic. But have you ever stopped and wondered what's really going on under the hood? Today, we are pulling back that curtain. We're going to demystify the incredible tech behind large language models, or LLMs. Let's get right into it.
You know, it really felt like it happened overnight. One minute, AI was this niche academic thing, and the next, boom, everyone was talking about it. The launch of ChatGPT didn't just capture our imaginations, it ticked off this massive global shift. It went from the lab to the living room, just like that.
And look, this wasn't just a fad for the public. The people who actually build this stuff, the researchers and academics, they went into absolute overdrive. Just think about this for a second. Before ChatGPT, the world was seeing, on average, less than half a research paper per day on LLMs. After it dropped, that number just went to the moon.
To be exact, it shot up to 8.58 papers every single day. We're talking more than a 20-fold increase. I mean, if you ever wanted to see an explosion of interest in a single chart, this is it. The race was officially on.
Which brings us to the big question, right? We've all seen what they can do. Whip up code, write a poem, answer some ridiculously complex question. But how? How do they pull it off? Okay, let's start peeling back the layers.
So here it is. This is the big secret. Behind all the mind-bending complexity, behind what feels like genuine intelligence, there is one surprisingly simple, fundamental job at the very heart of everything. And honestly, it's almost deceptively simple. But if you can really wrap your head around this one core function, you'll get the fundamental principle that makes every single one of these models tick, from the smallest ones all the way up to the giants like GPT-4.
And this is it. It's called language modeling. The entire goal, the whole game, after all that training on trillions of words, is just to get incredibly, incredibly good at guessing the very next word in any sentence. That's it. That is the core task.
So for example, if you say, I am sleepy, I start a pot of, the model doesn't think. It's not pondering its love for caffeine. It's just calculating probabilities. It's looking at all the text it's ever seen and says, well, coffee has about a 66% chance of being next. Water is possible, maybe 12%. It gives a score to every word it knows and then just picks the most likely one. It does that over and over and over, one word at a time, and that's how you get entire paragraphs.
Okay, so you might be thinking, wait, if it's just predicting the next word, where does all this incredible power come from, right? How does that simple task lead to writing a sonnet or debugging code? Well, it all comes down to a very specific recipe with 3 key ingredients.
There are 3 things that take this simple word predictor and turn it into the powerhouse we see today. First, you've got the engine, which is called the transformer architecture. Second, you have the fuel, just an unbelievable amount of data. And third, something that honestly feels a little bit like magic, a phenomenon called emergent abilities. Let's break each of these down.
The transformer, which first appeared back in 2017, was a total game changer. Its secret weapon is something called an attention mechanism. It basically lets the model figure out which words in a sentence are most important to pay attention to. So it learns that in "the cat sat on the mat," the word cat is way more related to sat than it is to they. This gives it a much, much deeper sense of context.
And this is where things just get kind of mind-boggling. You know, the large in large language model is not an exaggeration. We're talking about a scale of data and computing that is almost impossible for our human brains to really grasp.
Let's take a model like Google's Palm. It has 540 billion parameters. Now, you can think of a parameter as like a tiny knob that the model can tune, or maybe a connection between neurons. For perspective, the human brain has trillions of connections. So we're not quite there, but still, 540 billion is just an astronomical number.
And what about the data it's trained on? Meta's Llama 3.1 model was trained on 15 trillion tokens. A token is basically a word. A human being couldn't read that much text in 1,000 lifetimes. It has essentially read more of the internet, more books, more articles than any person who has ever lived.
Now, this might be the most fascinating part of the whole story, because when you take that brilliant transformer architecture and you fuel it with that incredible scale, something completely unexpected starts to happen. The models begin to develop skills they were never, ever explicitly trained to do.
Things like basic math, translating languages, or even logical reasoning, they just emerge. Think about that for a second. Nobody programmed the model on how to do arithmetic. But by getting so good at predicting the next word over trillions of examples, the ability to do math just pops into existence. This discovery is the reason the strategy has been bigger is better,
because pure scale leads to this surprising emergent intelligence.
So now we've got this incredibly powerful, scaled-up next-word predicting machine. But how do you take that raw engine and turn it into a helpful conversational sidekick like ChatGPT? How do you teach it to actually follow your instructions instead of just rambling on?
Just look at this comparison here. If you ask a raw base model to write a poem, it might just spit out a dry, factual definition, almost like a textbook. But a tuned model, it understands your creative intent and gives you back a beautiful poem. This change from a text completer to a helpful assistant is a very deliberate process.
You can kind of think of it like sending the raw model to finishing school. First, it goes through instruction tuning, where it's shown thousands and thousands of examples of good questions and good answers. Then comes the really crucial part, reinforcement learning from human feedback, or RLHF. This is where real people sit down and rank the model's different answers, giving a thumbs up to the good ones and a thumbs down to the bad ones. This slowly teaches it and aligns its behavior with what we humans find helpful and safe.
And this timeline of the GPT models tells that story perfectly. GPT-3 back in 2020 was all about raw scale and power, but the massive leap forward that we all felt with InstructGPT and ChatGPT, that came from this intense focus on human alignment. That whole refinement process is what turned a powerful machine into a useful tool for millions of us. So, we've covered the foundation, the recipe for power, and the refinement that makes them useful. But where does all this leave us right now? And what's just around the corner?
Well, for one, this tech is far from perfect. Models can still just make stuff up. That's the hallucination problem you hear about. But the future is already here in many ways. We're now seeing multimodal models that can see and hear, not just process text. And a whole new ecosystem of apps, like Microsoft's Copilot and all those ChatGPT plugins, is being built right on top of these models, changing how we all work and create.
To wrap this up, there's this really powerful idea from the philosopher Ludwig Wittgenstein. He said, "The limits of my language mean the limits of my world." The basic idea is that our ability to use and understand language is what defines the boundaries of our reality.
And that leaves us with one last, pretty provocative question. For all of human history, complex language has been our thing. It's what made us unique. Now, as these AI models get closer to mastering it, and in some cases even surpassing us, we have to ask ourselves, what will the limits of their world be? And how is that going to reshape our own? Thanks for joining me for this explainer.